So, in this session, I will discuss topic-wise question related to SI quantities, graph, and motion related to Unit 1 of IAL Physics. In the first question, which of the following quantities has the base unit kilogram meter square second minus 3? So, how we can work out the base unit? So, first, what we have to do, we have to write their formulas. The formula for the force, F is equals to ma. The unit of the mass is kilogram and unit of acceleration is meter per second square. So this will turn out to be kilogram meter per second square, or we can also say kilogram meter second minus 2. So this cannot be force. What about momentum? Momentum denoted by P, that is the product of mass and velocity. The unit of the mass is kilogram and the unit of velocity or speed is meter per second. So this will be kilogram meter second minus 1. What about power? Power is also denoted by P. Power is work done per unit time or energy, rate of work done or energy divided by time. The unit of the energy is joules and unit of time is second. But joule is not the base unit. Joule can be represented as Newton meter, so it can be Newton meter per second. And Newton is a unit of force. So Newton can also be expressed in a base unit as kilogram meter second minus 2. So in place of Newton, what we can write? We can write kilogram meter per second square. This is in place of Newton multiplied by meter, and that is divided by second. So when we simplify this, it will turn out to be kilogram meter square second raised to power 3. And if we move this in numerator, it will be kilogram meter square second minus 3. That's why option C is the right answer for question 1. What about work done? So work done, its formula is force into distance. Unit of force is Newton and unit of distance is meter. So Newton meter or joule, and Newton itself is kilogram meter per second square and multiplied by meter. So this will turn out to be kilogram meter square second square, or we can also write kilogram meter square second raised to power minus 2. That's why option C, the power, is a right answer. So kilogram meter square second raised to power minus 3 is the base unit for power. Is it clear? Moving on to the next question, question number 2. Which of the following statements describe the gravitational field strength, so means the value of the G, acting on a body? A gravitational field strength is force per unit length. It's not force per unit length because we have the formula weight is equals to mass multiplied by gravity, or gravity is equals to weight divided by mass. So it is, and weight is the force, so it is Newton per kilogram. So basically it is weight per unit mass. So that's why A cannot be a right answer. B is the right answer. Gravitational field strength, G, is the force, gravitational force per unit mass. Again, C is not the right answer. Potential energy per unit length, that's wrong. Or potential energy per unit mass, that is also wrong. So B is the right answer for question 2. In question 3, the diagram below shows the velocity of an object before and after a force applied. The magnitude of the velocity did not change. Which of the following arrow represent the direction of change in the velocity? So how we can work out the change in velocity or difference in the velocity? So if we say This one is the initial velocity u. This one is the final velocity v. If we are finding a change in velocity, so it means we are finding v minus u. So we need the result of v minus u. So we have the vector v. So first we draw a vector v. So this one is vector v. But then it is, because it can be written like v plus and in a bracket minus u. So vector v should be added to vector minus u to get the result r. As they're asking for the change in the velocity, so this is v. If this one is u, the minus u will be downward because opposite sign is there, so it means the direction should be different. So when we draw minus u, so minus u should point downward. And to get the resultant is always from tail of the first to the head of the last. That will be the resultant. So basically this vector resultant will be v minus u. So it matches with option B, or B is the right answer for this. As we are finding a change in the velocity in the question, the magnitude does not change, but we are finding the change in velocity, which is represented in terms of direction. So in a vector addition rule, basically what we did, to get the change in velocity, we need v minus u. And in vector addition, v minus u is equivalent to v plus and then minus u. So basically v is added to minus u. So we already have vector v and we have vector minus u. So v minus u, the resultant from tail of the first to the head of the last, that will be our resultant vector. That's why it matches with option B. Moving on to the next question, question 4. Two objects P and Q are at the same position at time t is equals to 0. So in the beginning, time t is equals to 0, both are at the same position. The graph shows how the velocity vary with time for each object. So this is a variation of the velocity for each object. Which of the following statements describe the position of P and Q at t is equals to 4? When you check this graph, because there is a positive velocity and negative velocity, so what positive and negative velocity shows, that it shows that it changes the direction. Like if positive, it was moving towards right, negative, it will move towards left. But for q, magnitude, the acceleration is changing, but and velocities continue to increase until it reach 1 meter. So it means q does not change the direction. Q continue to move in the same direction with decreasing acceleration. Initially it was having a greater acceleration, but its acceleration decreases as it moves from starting point to the final point. But for p, it moves towards right and then it moves towards left, because the magnitude of the velocity is, the direction of the velocity changes. And how we work out, because it is +1 and then it is -1, and it returned back to the same initial position, because the same area under the graph for moving towards right and towards left. So when we check the statements, the first statement, P and Q are both at initial position. They are not at initial position. P is at initial position, but Q is not at its initial position. P and Q are same distance from initial position. They cannot be same distance because P returned back to the initial position, but Q continued to move in one direction. So statement B is also not true. P is further from initial position than Q. That's also wrong. Actually, P is at its initial position. And the last one, Q is further from initial position. That's true. So D is the right answer for question 4. Is it clear? Discussion. Moving on to the next question, question 5. The table shows some physical quantities which row correctly identify scalar and the vector quantity. So scalar, when we work out, distance is a scalar, velocity acceleration is a vector, so option A is the right. But when we check the other option, time is a scalar, speed is also scalar, velocity is vector, force is vector, work is scalar, power is also scalar. So the correct option is A, in which the first quantity is distance is a scalar quantity where acceleration is a vector quantity. In question 6, a cyclist traveling at a speed of 4.2 meter per second accelerate 1.1 meter per second square in a time 7.4 seconds. The distance traveled. So how we can work out the distance traveled by the cyclist? Initial speed is given. A cyclist travel at a speed of 4.2. Acceleration is given. Time is also given. So we have the formula S is equals to ut plus half at square. So using this formula, when we substitute the values, initial velocity is 4.2, time is 7.4, plus 1 by 2, acceleration is 1.1, and time is 7.4 whole square. So 4.2 into 7.4 and then half into 1.1 into 7.4 whole square. This will come out as 61 meters. So C is the right answer. Which of these units is same as a Newton? So how we can work out which is same as a Newton or the base unit? We know F is equals to ma. The unit of force is Newton. Unit of mass is kilogram. Unit of acceleration is meter per second square. So it is kilogram meter per second square. Sorry. So kilogram meter per second square, or it is kilogram meter second raised to power minus 2. So kilogram meter second raised to power minus 2. So it matches with option B. So correct answer for question 7 is B. And the next question, a football is kicked at a speed of 12 meter per second at an angle of 35, the horizontal component of its velocity. So a football is kicked with a velocity of 12 meter per second, making an angle of 35 with horizontal. It will have two components, the one which is with an angle, that will be 12 cos theta, and the one which is against the angle, that is the vertical component, equal to 12 sine 35. So they are asking the horizontal component. So horizontal component is 12 cos 35. So for question 8, A is the right answer. Question 9, which of the following unit is only used with vector quantities? So joule, it's a unit of work or energy, and work and energy, it is a scalar. Meter, meter is a unit for distance and displacement, where distance is a scalar quantity and displacement is a vector, so it can be used for scalar, it can be used for vector. Newton, it is a unit for force or weight, that is always for vector, so C is the right answer. Power, the watt is a unit for power, so that is a scalar quantities, cannot be used for vector. So C is the right answer, which is only used for vector quantities. Why not B? Because B is a unit which can be used for scalar or for vector, as if it was distance it will be a scalar, and if it was displacement it will be a vector. In this question, question 10, the structure question, student carried out an experiment to measure the acceleration of a free fall. So student is finding the acceleration of a free fall, acceleration due to gravity. A ball bearing was released from position A. The time t for a ball bearing to fall distance L is measured, and this was repeated by decreasing the value of L. So we changes the value of L, the height is changed, and we are finding the time. Explain how the measurement obtained can be used to determine the acceleration due to gravity g in meter per second square. Your answer should include a sketch on the axis below that the student would expect to obtain. So what we can use the equation of the motion here. The equation of the motion, we have different equations of the motion, like v is equals to u plus at, s is equals to ut plus half at square, 2as is equals to v square minus u square, and s is equals to u plus v divided by 2 multiplied by t. But which equation is valid here according to this question? We know if an object is dropped and initially it is red, so initial velocity is 0. So initial velocity is 0, we are measuring the height, the length, and we are finding a time. So which equation involve initial velocity, time, and length or height? So this equation involves the final velocity, so we cannot use this one. This involves the height, the distance, initial velocity, and time. And unknown is acceleration, so we need acceleration. So we can use this equation. So according to second equation, we have s is equals to ut plus half at square, where a is the acceleration due to gravity. Then initial velocity is 0. So if initial velocity is 0, this equation turned to be s is equals to 1 by 2 at square. And the distance is L, acceleration is due to gravity g, and then t square. So what we can do, how we can find the acceleration due to gravity? So we can compare with equation of straight line, y is equals to mx. On y-axis, if we have length, on x-axis, if we have time square, so what will be our gradient? Our gradient will be 1 by 2g, or 2 times the gradient will be equal to the gravity. So how we can find the expression due to gravity? First we'll use this equation, s is equals to ut plus half at square, in which the initial velocity is 0. And then we'll compare with the equation of straight line. When we compare with the equation of straight line, on y-axis we have length, on x-axis we have a time square, and our gradient, because there is no y-intercept, so it means that it should be a straight line which is passing through origin, and the gradient of this line will be equal to half g, or g by 2. Is it clear, this question? That how we can find the acceleration due to gravity by using the operators given. In the next question, 11, a car travel north with a velocity of 50 meter per second, and while still traveling north, the car slows to a velocity of 20 meter per second. Which of the following is a change in the velocity? So it does not change the direction, it only changes the magnitude. So how we can find the change in the velocity? Change in the velocity is final minus initial. So this was the initial velocity and final. So the change will be the final minus initial. The final velocity is 20 or plus 20, minus the initial velocity is 50. So 20 minus 50, that's equal to minus 30. So B is the right answer for this question. In question 12, a student used a falling sphere to determine the acceleration of a free fall. The sphere is released from rest. So you can see it's a similar question. MCQs related to the question we discussed. That was question 10. Which two quantities would require fewest measurement to be taken in order to determine the G? So in order to determine the G, what we need, because initial velocity is 0, again we have this equation S is equals to ut plus half at square, or u is 0, so S is equals to 1 by 2 gt square. So we just have to determine the displacement or distance, and we have to determine the time, and directly we can find the acceleration due to gravity or G. So we need displacement in time to determine the value of G. In question 13, the velocity time graph for the motion of a ball is shown. Which of the following correctly describe the motion of the ball? For question 13, the statements, the ball, basically what is happening when we explain the motion of this, the speed is increasing for a ball, so means it is moving downward, it is accelerating. Once it hits the surface, it bounces back. But when it bounces back, it does not bounce back with the same velocity. As you can see, initially when it hits the surface, it was a higher velocity, example, say 5 meter per second, but or plus 5 meter per second. But when it bounces back, because it will lose some of energy during the impact, so it bounces back with a velocity lower than what it hits. So the ball is dropped and rebound to original position. That's not correct. Why it does not rebound to the original position? Because the speed at which it rebound, that is smaller speed as compared to the speed at which it hits the surface. So it means it loses some of its energy during the impact. That's why it does not bounce back to the same height. It will bounce back to a lower height. So position A is not correct. Option A is not correct. Option B, the ball is dropped and rebound to a lower position. That's true, because it loses some of its energy, and the speed at which it rebounds is smaller as compared to speed at which it hits. The ball is thrown upward. The ball is not thrown upward. It is moving downward because speed is increasing. If it was thrown upward, then the speed of the ball should decrease. The graph should be like this. The ball is thrown upward. That's also wrong. So B is the right answer for question 13. Then for question 14, which of the following graphs of displacement against time could represent the motion of the ball? So how we can work out the motion of the ball? As you can see, first the velocity is increasing and it is positive. Like if we divide the graph into two parts, because the question is interrelated. So from A to B, the velocity is increasing, and it is positive. And from this interval, if we say this B to C, and then from C to D. So when we check from C to D, this time interval is so short that is neglected. C to D, the velocity is decreasing, and it is negative. So we have to check which graph represent, like initially the velocity should increase. So, and if the velocity is increasing, it means the slope should increase, because for displacement time graph, the slope represents the velocity. So in this one, the slope is increasing, If the slope is increasing, the velocity is increasing. But when you check the second option, the slope means angle with x-axis. The slope is decreasing, so the velocity is decreasing. But what about the value of the velocity? Is it positive or negative? Or value of the slope? So when we check y1 and y2, like the y1 and y2, so y2 is above y1, so it means velocity is decreasing, but it is a positive velocity, not a negative velocity, so it cannot be A. Then when we check for B, displacement time graph, here the slope is constant. If slope is constant, the velocity is constant, so it cannot be B as well. So B is not also not a right answer. When you check C, slope is increasing, so velocity is increasing. And here the slope is decreasing, velocity is decreasing. And what about the value of the slope? That is negative. So option C is the right answer. Because first what we want the slope to increase and positive. Next, we want slope to decrease and it should be negative. When you check option D, the slope is constant, so velocity will be constant. That's why C is the right answer. Is it clear? Discussion 14. Okay, moving on to the next question. The space is not according to the marks because I reduce the space here. It's of 6 marks. In the question, a skydiver jumps from an airplane and accelerates until she reaches a terminal velocity. This is the acceleration time graph. At time t1, she opens a parachute and a second lower terminal velocity is reached before landing safely at time t is equals to 2. The acceleration time graph for a motion of a skydiver is shown. Explain the shape of the graph and you should refer the forces acting on the skydiver. First, we know the resultant force and acceleration are directly proportional. That's the first thing. So here, what is happening? When you check the first interval, the slope is decreasing. And if the slope is decreasing, or you can also check the value of the acceleration, not specifically the slope. You can also check the value of the acceleration by checking the y-axis. So acceleration is decreasing. So from the beginning till t1, the acceleration is decreasing, and approximately here the acceleration is 0. When acceleration is 0, it means it is moving with a constant or resultant force is 0. So possibility for a moving object when acceleration is 0, it will move with a constant speed. If it is a stationary object, then for a stationary object the acceleration will be 0, means the object is at rest. So how we summarize this? Explaining the motion of the graph. So from the graph you can clearly see in the beginning it is having the highest greatest acceleration at the beginning. So at the start or at the beginning it is having the greatest acceleration. Then what happened? Due to acceleration, the velocity will increase, which increase the air resistance, because air resistance and velocity or speed are directly proportional. If higher object moving at a higher speed will experience greater air resistance. So due to acceleration, velocity will increase, which will increase the air resistance. Air resistance oppose the motion of an object, the resulting force will decrease. Now, why the resulting force is decreasing? Because if an object is falling, if there is a falling object, the weight of an object is acting downward, the gravitational pull, and the air resistance is acting up. So resultant force is actually a difference of the two, weight minus air resistance. So if the air resistance is increasing, the resultant force will, because the difference will come out less, so resultant force will decrease. And what happened eventually, air resistance balanced with the weight, so no resultant force or acceleration. The object will continue with constant speed or velocity, which is known as a terminal velocity. Then what happened? At t is equals to 2, when skydiver opened the parachute, greater air resistance which decelerate the skydiver and lower the terminal velocity. So this is what happened in this motion of a skydiver, and the explanation is according to the graph. Is it clear, this explanation? So basically, first when the skydiver jumps, the gravitational force is there. But because he is accelerating, so due to his acceleration, speed increase. As the speed increases, the gravitational pull is same, but air resistance is the force which opposes the motion. Once air resistance balances with the weight, he will continue to move with a terminal velocity. But the moment he opened the parachute, the weight, the gravitational pull is not changing, but air resistance increases, which decelerate or lower the terminal velocity. Moving on to the next question, question 16. A car is moving towards a stop sign at a speed of 25 meters per second. The driver applies the brake. Uh, the driver applies the brakes 20 meters before the sign and decelerates uniformly to a rest just before the sign. Which of the following give the magnitude of the car's deceleration? So how we can work out the deceleration of the car? We know the initial velocity, we know the distance, we know the final velocity is 0, we need deceleration. The equation which relate these factors u, v, a and s according to equation of motion. So it is 2as is equals to v square minus u square. So 2 acceleration and the distance is 20. The final velocity is 0 and the initial velocity is 25, so it will be 25 square. So 2 multiplied by 20, that's equal to 40, and minus 25 square, or a is equals to minus 25 square divided by 40. So they are only asking which of them is giving a magnitude, so we don't have to include a sign. So 25 square divided by 40, so it matches with option C, which gives the acceleration, deceleration of the car, which stopped just before the sign. Question 17. An object of mass 8.2 kilogram initially at rest falls a vertical distance of 25 meters through an air with a final velocity of 20. Which of the following give the energy in joules dissipated by air resistance? So how we can work out the energy dissipated? This is related to the motion as well as the energy topic. So the potential energy, basically the energy dissipated as it is dropped, initially it will have a potential energy. When it is coming down, the potential energy is changing into kinetic energy. If there is a loss of energy, how we can work out the difference, how much energy is dissipated or lost due to air resistance or work done against the air resistance? So that will be the potential energy minus the kinetic energy. So potential energy is given by mgh. M is the mass, which is 8.2, g is the gravity 9.81, and the height from which it is dropped is 25. So potential energy is 8.2 into 9.8 into 25. And what about kinetic energy, which is half mv square? So 0.5, the mass is 8.2, and the speed at which it reaches the ground, it's 20, so it will be 20 square. So 0. So this will give us kinetic. When we take a difference of potential minus kinetic, we know how much energy is dissipated. So it matches with option C. So C is the right answer for question 17. Is it clear? In question 18, the graph shows how the acceleration a of an object vary with the time. So this is acceleration time graph. Now what is happening to acceleration? Acceleration is increasing. The value of the acceleration is increasing and it is positive. Because acceleration is on the y-axis, so acceleration is increasing and it is a positive value. So velocity time graph, because the slope represents the acceleration, for velocity time graph, the slope is equals to acceleration. So the slope should increase and it should be a positive slope. So which graph the slope is increasing? When we check here, this graph, how to work out the slope? Draw the horizontal line and check the angle with that horizontal line. So you can clearly see the angle is decreasing. So it means the slope is decreasing here. When you draw the horizontal line, check the angles. So you can clearly work out here the slope is decreasing as well. When you draw the horizontal line, here the angle is same. So it means the slope is constant. And checking the option D, drawing the horizontal line, the slope is angle with x-axis. So When you check these angles, you will find the angle is increasing. It means the slope is increasing. So option D is the right answer, in which the slope increase, it means the acceleration is increasing and it is a positive value. So D is the right answer for question 18. For question 19, a student measure the time t for a ball bearing to fall different measurement distance s from rest. Student uses this measurement to plot a graph with a gradient equal to acceleration due to gravity. Which row of a table shows a graph with a gradient equal to gravity or acceleration due to gravity? So how we can work out this? We have to check or compare the equation with a straight line. The initial velocity is 0. If the graph is between s and t square, look, you have the graph s is equals to ut plus half at square. So s, if initial velocity is 0, they mentioned it is start from rest, so initial velocity is 0. So it will be s is equals to 1 by 2 gt square. If I plot on, if I compare it with equation of straight line, y is equals to mx. On y-axis, if I have displacement, on x-axis, if I have t square. So my gradient will be g by 2, not equal to g. So this is not the right one, because they mentioned that which row represent a gradient equal to g. But if I rearrange this equation, like s is equals to 1 by 2 gt square, or I just rearrange 2, I move other side, so 2s is equals to gt square. Now if I compare with the equation of straight line, on y-axis if I have 2s and on x-axis I have t square, my gradient will be equal to gravity or g. So on y-axis if we have 2s, on x-axis we have t square, the gradient will be equal to the value of acceleration due to gravity. Is it clear? Then question 20, which of the following is a vector quantity? So when we work out the vector quantity, density is a scalar, energy scalar, momentum vector, viscosity scalar. So C is the right answer, that momentum is having a direction, magnitude as well as direction, where velocity, viscosity, kinetic energy and density does not have any direction. So these are first 20 questions we discussed from assignment SI quantities, graphs and motion. In the next session, I'll discuss more questions from this assignment. Any question related to the class today? We'll continue the discussion of this assignment in the next session as well. Any question or a doubt related to the class? Okay, so I'll end the session, share this assignment also with you.